Okay, so I'm gonna have this here, and just so I can actually refer to it, because that would be nice to do, I'm going to get the pseudo code, because the code will be pretty helpful for this. Get that. Okay, cool. And I'll have it here on the side. Okay, so we have an array A, it contains 1 to 25, and it's completely shuffled. So what is the largest and smallest possible value of pivot x in line 16 when we call that select function? So we'll actually walk through the code fully for this. Okay, so I called what? Select A, 1, 25, and 10. Okay, that's fine. So P is going to be 1, R is 25, that's good to know. So I will literally walk through line by line for this. So while R minus P plus 1 mod 5 is not 0, so that's 25 minus 1 plus 1. So while 25 mod 5 is not 0, it is 0, so I'm just going to skip all of that. I'll use a better color to mark on this thing. But yeah, I basically just skip all those lines. Those don't matter. Let's do red. Red's a good idea. And we'll just skip all of that. That doesn't matter. So G is going to be set to R minus P plus 1 divided by 5, which is just 5. Okay, so G equals 5. And I have to, from J equals P to P plus G minus 1, I have to sort A of J, A of G to G. So I just sort all the 5 element arrays I have. Okay. So once I've done that, then I have to call the select function again. Now, this will be interesting. I'm going to do select. I actually have to calculate the call. So it's A. It's P is 1, plus 2G is, G was 5, so that's 11. Then P plus 3G minus 1, so that's 15. And then ceiling G divided by 2. So 5 divided by 2 is 2. It's 2.5, it's ceiling, so it's 3. So that is the function call that results. Okay. Now that we have that, what this function call means is I'm going to say I have some sort of table, right? And within this table are all 25 numbers in some random order because they're all mixed up right now. Right, and the idea of this table is after having sorted each 5 element array, I am essentially picking out this array in the middle, you could say, right? I'll use a different color. I'm essentially picking out this array. Okay, something like that, right? So, and just to make it easier to illustrate, I will write every number in here. I'll write them in sorted, because it's easy to do that. But in reality, just know these numbers can be completely randomly in here. They don't have to be sorted. It's just faster if I do it this way. Okay, that's good. So where was I? Right, we're doing line 16. We're doing select A11, 15, and 3. So because we're doing that, I'm now gonna have to do another function call on there. So now I'm going to do select again. P is going to be 11, R is going to be 15, I is 1, or I is 3. So while R minus P plus 1, so that's 15 minus 11, which is 4, plus 1 is 5. So I'm not doing this whole while loop. That's good to know. Okay. G is then going to be equal to R minus P plus 1, so this time that's going to be a 1. So I'm going to go on and write that, because that's 15 minus 11, which is 4, plus 1 is 5, divided by 5 is 1. Okay. And for J equals P, which is 11, to p plus g minus 1. So from 11 to 11, which just means it's just not going to do anything, so I can cross that one out. That's fine. Okay, now I have to call x equals select again, apparently, which is what, going to be, g is 1, right? Yes, it is. So that's going to be p plus 2g, which is 13, p plus 3g minus 1, which is just 13, and then ceiling of 1 divided by 2, which is just 1. Okay. I guess I'll do that call again. So I'll write that. I'll write down what I just said. I did A 13 13 1. Let's see if that does anything. So I go back through this and again, and while r minus p plus 1, so 13 minus 13 plus 1, that is just 1. So 1 mod 5 is not 0, so I have to do this while loop now. For j is equal to p plus 1 to r. P plus 1 is 14 and r is 13, so I just don't do this for loop at all. If I is equal to 1, just return a of p. Okay, so I'm just going to return a of p. P is 13. So this function ends up returning whatever a of 13 is, which is here. So that is going to be x is equal to 13. There you go. That's like an example of an x that could actually be returned. So now that we've done that, right, the real question is, what is the minimum x that you could get from going through this algorithm, and what's the maximum x that you could get from going through this algorithm? And from here on out, it's mainly based on how the actual table is going to be placed, such that you can actually get a value of some sort, it seems. So what do I mean by that? Let's take a look. So I'm going to go on and get this here. I'm going to erase all these numbers in here. We'll get rid of all of them. Like this. Something like that. So I don't know. I'll do it like completely random. We'll see if that will do it. 20. What's that? Looping me. Oh, okay. One. I should probably, this would be a smarter idea so I don't have to keep track. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I already did 17, 18, 19, 20, 21, 22, 23, 24, 25, something like that. Okay, cool. So like this would be an example, right? And before we did any of like before we do the second select, we had to sort it, right? So because we're sorting it, I have to sort each 5-element array. We can do it via row or column, it doesn't really matter. So like I'll just do column because that seems easier to me. So what? 1, 4, 6, 10, 14. Like that. Okay? And then 7, 8, 17, 21, 22. 7, 8, 17, 21, 22.
You know?
3, 9, 13, 15, 19.
Yo, is my microphone working or no?
Yeah, it's working. You're fine.
Oh, okay. I was like trying to, yeah, okay. My AirPods are being weird, but okay, yeah, we're all good.
Okay. 11, 12, 16, 24, and then 5, 18, 20, 23, 25. And the idea is whatever shows up in the middle can be your potential x. So in this case, after doing all this, it seems 13 is there again. And you get the gist of it, right? Whatever shows up in the middle, that middle slot, counts as a pivot that can be used. Now we're going to actually try and optimize it to see what we can get for the minimum in there and the maximum. So we're actually going to try and put some numbers in now instead of just doing it completely randomly. So, okay, I'm going to try making it so that I get the smallest thing in there, right? I don't know. And how am I going to do that? I'll try and do one. So how am I going to get the smallest thing in the middle, right? The idea is I have to, I have to put in 1, 2, 3, right, for one array. I have to put in, 4, 5, 6 for another, because I have to get to that third mark. And then I have to put in 7, 8, 9 for this one. And then I can put in some random numbers here. And the idea is if I sorted them and found the median, this is what I'd find, right? And the reason why I'm sorting the arrays like this instead of what you might think, I could do something like, 1, 2, 3, 4, 5, 6, 7, 8, 9, like that. Like, the question is, why don't I do that? And the answer is because, right, via column, I am sorting each column to be in order, right? But the problem is via median, I have to sort each row to be in order. So because if I had like this, I don't know, right? Because of this, right, I have to say, okay, 3 is actually a much smaller median than 6 or 9, so then those have to go up top, all right? So I can't have it down here. So I have to have it such that I did 1, 2, 3, 10, 11, 7, 8, 9, 14, 15. Because here, it's like, okay, the first smallest median is here, the second smallest median's here, the third smallest is actually here in the middle. Because that is what has to be in the X. The third smallest median of the 5 arrays. So that's what ends up being in the middle. So really, the only way I could get the smallest median is if I put a 1, 2, 3 in here. So 3 is the first smallest, 4, 5, 6, so 6 is the second smallest, and 7, 8, 9, so 9 is the third smallest, which makes 9 the median of medians, making it returned, and I can make X equal to 9. I can do the same way, except this time I'm going to try and do the biggest. I want the biggest ones, right? So because of that, it's the same concept, right? I have to have the biggest down here. So the best way to optimize it is like this, right? So I can have 23 as the first biggest median, 20 as the second biggest median, and 17 as the third biggest median, right? Because it's in the middle. So because of that, 17 is like the biggest possible number I could have as a median of medians, and 9 is the smallest. So that's how you would manage to get number 5 if you wanted to prove it using the code itself.
So basically, like, you're picking that spot because, like, when we did the algorithm before, we got 13, and so we go to the 13th spot, and then you're basically just putting you're counting like up to that median essentially, and then moving down a row each time until we hit that spot, and that's how you're getting that essentially.
Pretty much. So the way I actually get like the spot in the middle, right? I did select A11, 15. So since I said a column is like, an array of 5 elements, the 11, 15 part, that is the start of that array and the end of that array, meaning I select this column in particular. Once I do that, it then narrows down to 13, 13, in which I'm no longer looking at the whole column, but at the actual middle part instead, which is why that middle part is so important. And one thing you might notice, the 10 in this problem is completely irrelevant. It doesn't matter. The 10 is only relevant when you are working with a table that does not have a mod 5 number of spots, right? In this case, we have 25, Because of that, since 25 divided by 5 is 0, we don't have to worry about the I. The I is irrelevant.
Well, isn't that so? I mean, the thing you were doing with like the 10 minus 1 and then just counting up
No,
9 from
that
the
just turned out to
beginning.
be wrong. Like that was just outright wrong.
Oh,
Yeah, that
okay,
was
that
just
doesn't work at all.
incorrect. Yeah,
Damn, that would have been nice. So that's just like a coincidence that that worked.
it was
Okay.
just complete coincidence. The problem he chose is just like it just so happened that that worked. In reality, I has nothing to do with it, like at all. So, yeah,
So I
like
mean, yeah, I was getting that with like the select, like if you saw in the chat earlier, I was getting the 13. So I think I have that down. I'm just trying to think like for other problems, like if something were to come up, like essentially how it works. I just like to kind of have like an intuitive understanding, so I don't have to read
right,
through the code on the test. But essentially, like I'll do that select algorithm um, until the I equals, I guess, 1 in this case. Or it's just until it's not a. Why did you stop at 1313? Is
So
that just
I
because
stopped
the.
at 1313 because the idea is when you have 13 and 13, right? This while loop must activate. It must turn on because whoa. Sorry, hold up. Okay, this while loop must turn on because it's 13 minus 13 plus 1 mod 5, right? So
Which
that
doesn't
is
equal 0.
1 mod 5, right? Which doesn't equal 0, meaning you actually have to run that while loop. And what ends up happening is, this doesn't execute. What ends up happening is this line. That's the line that makes it so important because since we're putting in I is equal to 1, which is literally like right here, I have to draw in a different color, but I equals 1 is right here. The moment we call that, that
Mm.
means that we have to return whatever A of P is, and we set P to be 13. Because of that, it must return the index in the middle, because that is index 13.
Okay, so let's say that like completely new example where we ended up with it's like very similar to the select. You don't have to rewrite this, just kind of like
Sure,
based on like what we already had.
sure.
Let's just say that the select ended up being a 14 13 1, and then in that case, it would still be 2 mod 5, which doesn't equal 0, but we
Right.
would be returning spot 14 essentially.
Well, actually, no. You said 14, 13, right? So
Right. So P would be
that would
14.
be 13 minus 14 plus 1, which is 0.
Oh,
That would end up being
Oh yeah,
0.
you're right. You're right.
Yeah.
I got the P and the R flipped. Okay.
Okay, so if you want to flip the P and R,
I'm trying to think. Does that do anything? I
I
don't think it.
mean, if you flipped the P and R, then that's 14 minus 13 plus 1. That's 2 mod
Oh yeah,
5.
yeah, yeah.
Yeah.
That's what I meant to do. Yeah. Would
Okay,
that? So
okay.
then would that spot? Or no, it
Yeah.
doesn't matter still because then the spot would still be return. It would still be the
You
same
would you
spot.
would
It would
just
still be
return
13.
AFP. Yeah, and it'd still be
Yeah, which is
13.
13.
Yes.
So it's always going to be like if I were to like let's say it was a an array of like 30 elements, I would just look for essentially like the middle spot of that. Like if I were to draw it out like you have right now, I would
Yes.
just kind of look for the middle spot and then just like count
Yeah.
I guess until yeah, like the one, two,
Until
three,
you
four,
get to
five,
the
six, seven, eight,
direct
nine.
middle. Yeah, something along the lines of that. The only thing is, if you end up getting like an even number of rows or something like
Mhm.
that, then it could be a bit
Then it
different.
doesn't. Yeah, then it
Yeah,
would be
it
a
could be a bit
burden.
different. I'll try that example just to make sure. So, like, I think Professor Ding mentioned that. Let me go on and try that. So, I don't know. You said 30, right? So, what? We'll just
Yeah,
do
let's do
like
30.
1, 2, 3, 4, 5, and then half that, and then in thirds, and in thirds, like that. That's 30. Okay. Now, the question is
Mhm.
if we put in, I don't know, like A130 I doesn't matter, then what are we
Mhm.
going to do? So what you this is obviously not executing initially. Um, yeah, I'll draw that. I'll just keep drawing in red. Red will work. Okay, so that's not going to happen initially. G is going to be 6, and then you're going to do what? A of 1, A of 7. You sort all that stuff. Then you do the select function, which is going to be What is it going to be? Comma, I don't know, select, I don't know, I don't care. So you have A, and then that's
13.
going to be, P is 1 by default, so that's just plus 2 times 6, that's 13. That's going to be 18, because it's 19 minus 1. Then it's 6 divided by 2, which is just 3. You have that, so then you'd run that again. 18 minus 13 plus 1 is not
But right there,
equal to
you would
0.
stop.
Right. Yeah, you'd have to stop because here, well, you don't have
Wait, no,
to.
no, no.
No,
18,
you don't. It's
18 minus
different.
13. Yeah, never mind.
Yeah.
That would equal 0.
Yeah. 18 minus 13 is 5 plus 1. 6 mod 5
Oh, no,
is
no.
not 0. So you do have to run this. And you would have to go
Yeah.
through that. You have to go through that J loop, I think, too. Because J is equal to P plus 1, which is 14. And you have to do it from 14 to 18. So 4 times, you'd have to exchange A of P with A of J if it's bigger. I think this is just a sorting algo thing. And it also, keep in mind, this sorting algo is only happening in the middle. It's not happening anywhere else, so it's just a way to sort your numbers to make sure, I guess, but that's about it. It doesn't seem to do anything else.
In this case, I mean, is it not the same thing where we'd end up in spot 13 and then we're counting that again, or is it different?
It seems like we will be ending up like in one of these middle two spots. Like I'm pretty sure this is going to be the same thing. The only thing I'm curious of is which spot you end up in, the top one or the bottom one. That's what I'm curious in.
Well, if you just return A of P, yeah, it'd be that top spot again.
Yeah, exactly. But the problem is I is not 1, I is 3, so we can't do that.
Oh, right.
Right. So let's see what we have to do then. So, okay, if I is equal to 1, it's not. P is equal to P plus 1, I is equal to I minus 1. Okay. G is equal to R minus P. So R is still 18. P is not 13 anymore, it's 14 now. So 18 minus 14, which is 4, plus 1, which is 5, so that's 1. G is 1. I'll write that, I guess. And
Wait,
then,
why did you go back to G? Don't you continue the while loop after?
Oh, wait, yeah, you're right, my bad. You're right. So what, P is 14 now? Yeah, that's right.
Right.
And
I equals 2, and then you go back.
Yeah, so then you do 18 minus 14, that is 4, plus 1 is 5. Oh, okay, so you leave
Now we got
anyways.
0.
Okay, so now you have to leave that loop. You go to G. G is now just actually going to be set to 1. And J is equal to P, which is 14. You do 14 plus 1 minus, so that doesn't execute because it's already sorted. Makes sense. Then you do X select again. All right, select, and we're gonna do A, and whatever P plus 2G is, G is 1, so you do 16, and you do 16 again, because G is actually 1, you do ceiling, which is just gonna be 1, so you seem to do spot 16, whatever that is. Is that what it seems to be?
Looks like it.
Yeah, okay. 12,
So
13, 15. Ah,
row,
okay.
first column.
And this one returns the bottom spot. It returns the bottom spot. That's index 16. Yeah. That's what that does. Interesting. Okay.
Oh yeah, you only wait. Why isn't it the first column, fourth row? Why is it?
Why is? Oh, what? Oh, are you saying?
Why-
Are you saying like this one should be index 16?
Yeah, or no?
No, it's the other way around. It's that one mainly because right when you are asked to when we did the first select, we found G as 6, right?
Mhm.
Right. That means there are I believe 6 5-element groups, right? If I remember that right. Yeah, that would say that's like 6 5-element groups. And the way it does the actual sort is based on G. So I imagine that means that it's like this is a group, that's a group, that's a group, that's a group, right? So that would
And
be like,
that makes sense. So it's in the fourth row just because like that's what the 16 would be in the fourth row if it was completely ordered, but because we're ordering each row, like when we group them, that 16 is going to end up in the middle.
yes, yeah. And
Okay, that
yeah,
makes
so it
sense.
seems like if it's like an even numbered amount of rows, then you just assume the bottom middle, like this node.
Hmm.
Otherwise, just like up here, you just assume the
The
middle, the
absolute middle.
direct middle.
Yeah.
Yeah, exactly. But otherwise, it'll go out to that. Okay, that was the important thing. So, in case if you do get like a equals 1 comma 30, that'd be good enough. Yeah.
And then so the min would be for this one, it'd be like 12, right? And
Yeah.
then the
Because you could do
max would
this.
be 9, I guess. Or no, sorry.
The minimum is 12.
30
That's
minus 9,
right.
so 21.
Yeah. Or I think it'd be 22, just because of like
Or yeah,
counting.
sorry, that with the indexing, yeah.
30, 29, 28, 27, 24, 23, 22. That's right. Yeah.
Yeah.
Yeah. That would
Okay,
be
that
how it
makes
would work.
sense.
Okay, cool. So yeah,
Well,
that's how you
well,
actually do it. Sounds good.
can you hear me?
Yeah, I can hear you.
Yeah, sorry, I went offline before. Do you mind just briefly going through it for me?
I'm recording right now, I believe. So you can just watch that.
Yeah.
I'll probably post that. It shouldn't take as long. I'll just post the unedited clip, but that should be good enough.